Hello and welcome to Vodcast 5.3. Our previous two vodcasts overviewed continental drift and plate tectonics, and in this vodcast we will shift our attention to plate boundaries. As a real quick overview, when we use the word plates, we're essentially referring to these rigid chunks of lithosphere. And the plates will move relative to one another because we can think of them as almost floating on the asthenosphere, which is the weaker rock layer just below the lithosphere. In this image of Earth's plates, you see some red colored lines, some blue colored lines, and some green colored lines. What they all have in common is that they represent plate boundaries. And now we will go into detail about what's happening at these three specific types of boundaries. The first boundaries that we'll consider are divergent boundaries. Divergent boundaries are known as constructive margins because lithosphere is being created at these boundaries. It's very important to note that new ocean crust will be formed at divergent plate boundaries. Put as simply as possible, at divergent boundaries, two plates will be spreading apart. What causes them to spread apart? Well, the spreading apart of plate is caused by upwelling of hot mantle material. In this image, you can see some of that hot material arising from the asthenosphere, and as that material reaches Earth's surface, it will push the plates apart and form new oceanic crust in the Rift Valley shown. What's kind of cool in this picture is that knowing that divergent boundaries are constructive margins, you can think of the oceanic crust found very near the Rift Valley as being quite young, almost like an infant or a toddler. And as we move out away from the Rift Valley, the crust will get older and older. In other words, as we move away from the Rift Valley, we will find progressively older crust, because the newest crust is forming at the Rift Valley and pushing the older crust away from the Rift Valley. I want to show you some pictures of the Great African Rift. The Great African Rift is a continental rift, and it is associated with divergent plate boundaries. I know we focused our conversation on seafloor spreading, but divergent boundaries don't have to occur underwater. And the Great African Rift Valley is a great example of a divergent boundary that can occur on land. Whether the Rift Valley is forming oceanic crust or continental crust, the mechanism is the same. At divergent boundaries, we have two plates being pushed apart, and they're being pushed apart by hot materials from Earth's mantle. The second type of boundaries we'll consider are convergent boundaries. Now, divergent boundaries were constructive boundaries because we are creating new crust, but convergent boundaries are going to be destructive because we will see the destruction of crust at these boundaries. Conceptually speaking, with divergent boundaries, we had two plates being pushed apart. With convergent boundaries, we have two plates running into one another. At convergent boundaries, the plates will run into one another, but it gets a little bit more complex than that. At convergent boundaries, one of the plates will slide underneath the other plate, and we call that subduction. And just like if you're a football fan, you may know what a cut block is. A cut block is when an offensive player dives at the legs of a defensive player. The offensive player will go low, the defensive player will go over the top of him, and we call that a cut block in football. Well, at convergent boundaries, it's kind of the same idea. One of the plates will go underneath the other plate as they run into one another. It's very important to note that at convergent boundaries, we see mountain building and we see volcanic activity. And a really good example to consider is Mount Hood, which is found in Oregon. Mount Hood is part of the Cascade Range, and the Cascades are a chain of active volcanoes. Those active volcanoes are created by the science that's occurring near a convergent boundary. In this image, we see that the oceanic lithosphere is subducting underneath the continental crust, and water driven from the subducting plate will trigger melting in the mantle. And as those hot plumes work their way to the surface, we're seeing the creation of a magma source for this volcanic arc. If you take a look at all of these images, you'll notice that volcanic activity will typically involve subducting oceanic lithosphere. However, not all convergent boundaries will produce volcanic activity. If we focus on image C, we see the subduction of continental lithosphere underneath other continental lithosphere. And at this convergent plate boundary, we would see mountain building occurring. So a few key things to keep in mind. At convergent boundaries, two plates are moving together towards one another. In cases involving oceanic lithosphere, the cooler, older oceanic lithosphere will sink into the mantle at subduction zones along these convergent plate boundaries. And if we're dealing with two continental plates that are converging, we will see mountain building occurring in those regions. But one key feature to keep in mind with all the images shown is that at convergent boundaries, there will be subduction occurring. One of the plates will slide underneath the other plate. And it's that subducting plate that's being destroyed, hence why we call convergent boundaries destructive margins. And although I overviewed this on the previous slide, I'd just like to stress once more that Mount Hood is a great evidence of subduction. In order to get these awesome chains of volcanoes, oceanic lithosphere must subduct at a convergent plate boundary. Our last consideration in this vodcast are transform plate boundaries. Transform plate boundaries are called conservative margins because we are not seeing the creation nor the destruction of lithosphere at these boundaries. Conceptually speaking, with divergent boundaries, we have two plates moving apart. With convergent boundaries, we have two plates running into one another. At transform plate boundaries, the plates aren't running into one another, nor are they getting pushed apart. They're sliding past one another. Almost like when you rub your hands together, that same motion is occurring with these two plates. Now, if you rub your hands together, your hands will start to warm. Sometimes when plates slide past one another at transform plate boundaries, they can be a little rough on each other. And transform plate boundaries are notorious for triggering earthquakes. We find transform plate boundaries all around the world, but the one that you're probably most familiar with is the San Andreas Fault in California. And anyone that knows anything about California knows they have a lot of earthquakes out in that region. In Chapter 6, we'll go into more detail about earthquakes. But for now, just know that transform plate boundaries are associated with earthquakes, but they are not associated with volcanic activity. Okay, that concludes this video podcast. Hopefully this vodcast helped you develop an understanding of the three types of plate boundaries. In our last vodcast for Chapter 5, we will consider some additional evidence that supports the theory of plate tectonics. And I'll also explain the formation of the Hawaiian Islands. Okay, that's enough rambling for me. I'll see you in Vodcast 5.4.